Julie Maybe, and I'm the interim associate dean of arts and humanities at Lehman College. Until like last month, I was chair of the philosophy department, and I'm also the director of our interdisciplinary disability studies minor. And welcome to today's showcase. And our first speaker today is Rinat Levy-Cohen, who is the Director of Innovation from Fairfield College Preparatory School in Fairfield, Connecticut. And so thank you very much for joining us today. And I look forward to learning from you.
Nice to meet you all. Thank you for coming. So today I'll talk about the different kinds of assessments we do in our innovation camp. So I'm the Director of Innovation at Fairfield College Preparatory School. It sits on Fairfield University's campus. And a few years ago, they built an innovation center and brought me on to build up their programming. So I'm here today to show you kind of the philosophy behind our teaching in the innovation center and examples of things we've been doing with our students and faculty. So I know it's about AI, but there was room for not just talking about AI, but about authentic assessments in education. So that's really the focus of my session. Blocking my view. Okay, so the way we design teaching and assessment in the Innovation Center, it's really driven by improving learning. We do our best to make all our units, projects we work on with teachers interdisciplinary. And when I speak to teachers about innovation in education, I explain to them that it's not just about technology, it's also about applying different methodologies and sometimes both. It just depends on what your learning goals are. And what we look at is really addressing the gap between what is taught in the classroom and how you can really apply it in the outside world. I think that's something that's lacking a lot in education. And there have been a lot of speeches about why you're teaching things and students asking, well, why am I learning about the Pythagorean theorem? What am I ever going to do with it? So that's what we're trying to do in our educational programming. And obviously, when we look at these, when we design curriculum, we look at educational technology. Sometimes it's high tech, sometimes it's low tech, but really what drives the design is the teacher's learning goals. What is it that you want your students to achieve? How will they get there? What kind of technologies, methodologies do we have to use? And this is the framework that I use often when I work with teachers. I'm sorry, it's cut off on the side. But we look at their learning goals. We talk about what kind of technology, whether it's pen and paper versus a 3D printer, what will get us to those learning goals. Focus on hands-on learning, interdisciplinary work, assessments that are applicable, and bridge that gap between what they learn in class and what they can do with it outside. Of course, being inclusive and equitable, related learning. So this is our innovation center. I wanted you to just see what it is. That's just one part of it, but it's a huge center with multiple rooms. Over the course of the year, it started with an event space. I wonder if I can turn off this slide. We have a large event space. We have an innovation classroom. Students come in from different classes, disciplines, and we do activities with them in there. We have an esports lab. We are currently renovating our film and video production lab. We have a wood shop and a fabrication lab with 3D printers, laser cutters. So we have a plethora of technologies down there that really give us the flexibility to reach our learning goals with different kinds of tools. The first thing I wanted to talk to you about is the project we developed specifically for the course I teach, which is called Introduction to Engineering and Digital Fabrication. Students took an Arduino device They have to go out, try to figure out a problem. A problem maybe that a parent has, a problem in society, and try to solve it. So essentially, they take everything they learned. You're welcome to come in. So they learn about 3D printing, laser cutting, basically production skills, and then they apply it to solve an actual problem people have in the world. And it was very interesting to see what they came up with. We had a student who was just learning how to drive, and he and his friends were struggling with parking. So they designed a parking assistant tool using a 3D printer, and this turns into a computer essentially. Arduino is a small programmable computer. So you put in codes, connect wires, and you can make a device. So that was one problem that student solved. He and his friends have problems parking, and they made a device to assist them. We had another group of students that lived in a little bit of an unsafe neighborhood. So they ended up developing an alarm system using Arduino. So I just think it's really important to develop assessments that bring what they learn in the classroom to life, show them how they can apply it. And we do that with, different technologies. This is another example where students, this was a fun activity in my class actually, where we had them develop any kind of device that will help them. Some of them made phone cases, some of them made cup holders for their grandmother that walks with crutches. But we teach them a lot about the engineering design process. They go through sketching to modeling it on a computer, in this case Tinkercad, and then we actually make it for them with our laser cutters or 3D printers. And what's another layer to these assessments is that we have them actually participate in an authentic research poster session. So after they built their devices, we set up our innovation center like a poster session. They made a research poster, and we had about 100 people walk through that session, and they had the experience to present their work in an authentic research poster. So we also do a lot to prepare them for college as part of their high school education. This is an example of church history class. And we worked with the church history class and a biology teacher. The church history teacher's goal was to basically show his students how history is written. How do historians write history? And we thought a lot about how can we convey that to them? How will they understand that what they're learning in class actually may help them become historians one day or archaeologists? So we ended up building an archaeological dig site. We bought actually artifacts from ancient Rome. Not that expensive. There's a lot of things you can buy online. They had to dig them out. They had to take them out of the sand like archaeologists. They had to write everything about the data, just like an archaeologist would do. They found letters from that time, so we kind of brought them back in time. After they collected all that data, we sent their data to our AP biology class, who then carbon dated it. So they know what year it was from. And then when they received that scientific report, they were able to go back and write their theory of what happened at that time based on pottery they found, the coins, the letters, and so on. So that was, I call it a low-tech example of authentic assessments, but really bridging that gap between what you learn in class and what you can actually do in real life with those skills. So that's just more pictures from that activity. Do you have some questions so far? Because I have so many units to go through. Yes.
Make that comment.
Yes.
For example, low-tech and high-tech technology.
Yeah.
That in the process of creating these projects,
Right.
you think about it. And that's really important that That's something that I find very interesting because something that we've been talking about for years in the educational technology field is that technology should come as a tool, not the end.
Right.
And so you think about your curriculum, your learning goals and all of that, your pedagogy, that comes first. And then second comes the technology.
Right.
And not more.
True.
Sometimes it's difficult not to realize that, but I think that's really important that you got that.
Yeah. Thank you. I appreciate it. Okay. Yes.
So for the interdisciplinary project, it was individual faculty in these departments who took the initiative to work together on projects like that?
So my role is basically to work with the teachers and to get them to do these things. Sometimes it's not easy because their schedules are really busy and packed, so it's hard for them to get together. So sometimes I will get together with one teacher and explain to them what we came up with, and they contribute to that partnership. So in this situation, I had several meetings with our theology teacher, and then I brought it to the AP biology teacher and I asked him, like, how can you add to this unit? Like, how can we further develop it? And he came up with the idea of carbon dating the data. So it's, you know, my background is actually in second language learning, and somehow I ended up being in EdTech, but I'm not a math teacher. Like I need to work with those teachers that specialize in every discipline and just work with them to create what we create. So this is a new project we started this year. The school I work at is a Jesuit Catholic school, and our mission is basically the Catholic school's mission, you know, making the world a better place, helping, you know, the poor, all those things. So the idea for creating a hydroponic farm in our innovation center came from food insecurity, helping people in our community. So this was an amazing interdisciplinary unit that we came up with. It started in my class. My students actually built the hydroponic systems as part of their engineering work in my class. We later brought in our math teacher who worked with her students to track the growth of the seeds, the level, the pH level in the water. We put different chemicals in the water. So hydroponic basically is planting with no soil. It's just water, and you put chemicals in the water. Then we had our environmental justice teacher talk about food insecurity and why farms like these are important in today's world and how can we help people in our community. And then, of course, we had mission ministry involved, kind of explaining our mission and how that relates to hydroponics. So I can show you a quick video. So this is a video showing how they built the hydroponic systems. So how do we connect my audio to? Oh, it's not, yeah, it's showing the.
I forgot you were here, still here.
Hello, you can come in. Do you guys see that pictures?
You need to connect the headphone jack to the audio system.
It's on the other side. No. Here, maybe the Samsung? What am I supposed to have?
You select that.
Which one?
On the, on the audio system or on the other computer.
So at the bottom,
So which one? Which system you want to use? Should be this.
do you know how to,
Yeah, this is the audio. Yeah, the mic is now on one.
not going to work?
No, you may want to download. Or if you have this connection, how it happens.
Let that gentleman.
Can you skip playing the video?
Yeah,
What's
it's
the
fine.
next slide?
Yeah.
Yeah, I think we can.
Okay. How much time do I have left?
We started a little bit later, so you still have,
Yeah, you still have time.
maybe 10 minutes.
Okay, thank you. Okay, so after they build the systems, they did research in their different classes, like I mentioned, in math and environmental justice. And again, they did an authentic poster session. People walked around, listened to their projects, and gave them feedback. So this is an example of how we show our students why they learn the Pythagorean theorem and how it's applied in real life. We chose to focus on water navigation. So we brought in a coastal engineer who's actually an alumnus from our school, and he explained the Pythagorean theorem to them and how it's applied in sailing. So we did a sailing activity with our students, explained to them how the Pythagorean theorems apply to actually sailing a boat. So that was also another significant, left a significant impression on our students. So in one of our AP Physics classes, they were challenged with designing gravity-powered cars. So how can you design a car that basically is powered by gravity? We had our students design the car in 2D, so flat, in Adobe Illustrator. After they designed it, we basically threw it into our laser cutter, and they had to assemble all the parts they put together. And assemble the cars. And they had a competition in the end of which car moved faster and furthest, which is also an example of, engineering, math, science, how all those things go together. They end up being engineers in the end. They will end up using these skills. But these are things that didn't exist in education a few years ago. I wish I learned this as a high school student or a middle school student. So we're really happy to be able to bring this to our students, and we do a lot of community outreach to bring it to other schools. We also teach our students other engineering skills, for example, building earthquake-proof buildings. So that again comes from our mission of bettering the world, making it a better place, safer place. So how did you design an earthquake-proof building? Our students learn about different engineering techniques. We built a shake table on which they put the table, which mimics seismic waves that occur during an earthquake. We brought an engineer from Sikorsky. If you know, they make the Black Hawk helicopters for the US Army. So he does a lot of testing. So he brought his expertise on that. We programmed a microbit, which is also a small programmable computer, to measure the acceleration of the building while it's undergoing those seismic waves. So we really try to make our work down there in the Innovation Center as innovative as possible, interdisciplinary, really showing them what they can do with those skills in actual real life and connecting it to our mission as a school. And that's part of the, Innovation Center's educational framework. And that's it. So if you have questions or comments, welcome to receive them.
Some of this continued on into Fairfield College, as far as like learning communities and things like that.
So we've had several partnerships with them. We have a professor that works with us. He comes in and teaches biomedical engineering. They also have, what's the name of that group? There's a group for young Black engineers. It's a chapter in the university, and we're starting one in the Innovation Center. So we bring in their students and meeting with them in our Innovation Center, having them mentor our students. So we try to collaborate with the university as much as possible. Scheduling wise, it's complicated.